Putting the drivetrain up front with the engine has allowed the manufacturer to eliminate a very heavy frame, solid rear axle system, and the drive shaft. As a result, the vehicle can be smaller and lower externally, and yet retain the same interior space. Most people like the improved handling and traction characteristics of front-wheel drive because proportionally, more vehicle weight is over both the driving and steering wheels. However, the higher cost of repairs to some front-wheel drive components compared to conventional rear-wheel drive systems comes as a real shock to some people, especially those who believe a vehicle should last forever with little or no maintenance. On the other hand, regular inspection and preventive maintenance on front-wheel drive components will usually result in normal long service life with few problems.
In this program, you will be shown some ways to check various front-wheel drive components with basic tools and equipment you already have, such as miscellaneous hand tools and a stethoscope. Most of these checks can be performed quickly and easily each time a front-wheel drive vehicle is in for service. In this way, you'll be able to spot potential problems and recommend low-cost repairs before they develop into serious problems, which could result in repairs costing hundreds of dollars.
Let's begin with front-wheel drive constant velocity joint checks. Since these joints must transmit more drive torque than regular U-joints and operate at greater angles without vibration, they are, out of necessity, more complex and therefore more expensive. The precision machining to close tolerance of all components means that dirt and moisture, or lack of lubricant, can quickly damage the bearing surfaces. Should your customer describe a clicking noise on turns, vibration or clunking on acceleration or deceleration, or mention a broken dust boot, explain the necessity of prompt repair.
Should the vibration become excessive, it will often cause extensive damage to the transaxle unit.
A short road test with the customer is advisable to verify any noises they may be concerned about. To pinpoint a clicking noise, drive the vehicle into a slow, tight turn, first in one direction and then the other. The defective joint will click faster when it's on the outside wheel. With the car on the hoist, first examine the dust boots for cracks and deterioration. You may see signs of grease spun out from the boot if it's broken on the larger end. A broken boot will usually verify the defective joint. Mechanical checks of the CV joints and axle shafts can be done with the vehicle on a drive-on hoist or by placing jack stands under the outer ends of the lower control arms. This puts the drive shafts in a normal operating angle. With one hand, hold the front wheel and twist the shaft back and forth with the other. If you feel any free play, it means that either the outer axle and joint splines or the joint itself is worn. Next, check for vertical movement of the shaft. Looseness in either case indicates service may be required and partial disassembly will be necessary to verify which component is worn. To check the inner CV joint for looseness, first move the shaft up and down. A little play is normal here on some joints. Experience and reference to the vehicle service manual will help you in this area. Move the inner joint housing up and down to check for looseness in the transaxle output bearing and then check for rotational play. Also, look for fluid leaks at the output bearing seal. Signs of wetness here are often a result of a defective inner joint vibrating, which can cause bearing or seal wear. Sometimes a clicking outer joint can be detected with a stethoscope, but don't expect it to be as loud as on the road, since very little torque is being applied. Pressing the brake lightly may make the clicking more audible. While you're at it, listen for wheel bearing hum or buzz, as this is also a sign of trouble. Next, move across to the transaxle housing, sounding it out with the stethoscope while the driver accelerates and decelerates. Listen for clunking and vibration, which could indicate faulty joints. Listen to the opposite side also, to be sure the noise isn't telescoping through the transaxle unit. Here's a valuable service tip. On some vehicles, the half-shaft assembly can be removed without disassembling the spindle from the control arm, even though the bearing holds the rotor into the spindle. Do not move the vehicle unless you install and tighten a stub shaft, usually the old one, into the spindle and rotor to hold them together. Otherwise, the bearing will surely be damaged even if it doesn't come apart while moving the vehicle. When servicing CV joints and half-shaft assemblies, always refer to your shop service manuals for proper procedures and safety practices. This will always save you time, and you will avoid damaging other related components.
The increasing use of rack and pinion steering systems to save weight has also become popular since the mid-70s. Although this system has fewer parts to wear, dirt and water contamination through broken boots can cause premature failure and costly repairs. Here again, regular inspection can often identify a potential problem, so let's cover some quick tests on this system.
Begin at the steering wheel to check for excessive free play as well as stiffness or humping. On some vehicles, such as this Fairmont, there are two small U-joints in the steering shaft, operating at sharp angles. Looseness here will cause free play and clunking, while seized or dry joints can cause stiffness or humping. Moving down to the pinion shaft, check for both end and side play. Any looseness here means removal and service of the rack and pinion unit to correct this problem. Next, examine the dust boots for damage and sealing. To do this, squeeze one boot while watching or feeling for the other to expand as air is transferred through the rack or vent tube. Air leakage here means dirt and water could be drawn in to contaminate and damage the mechanism. Recommend removal, inspection for contamination or damage, and necessary repairs, along with boot replacement. On power rack and pinion units, listen and feel for signs of power steering fluid in the bellows boot and look for external leaks. This means leaking seals at either the rack shaft or pinion spool valve assembly. Removal for service or replacement will be required. Check the rack shaft end bushings by feeling for play through the boot while you push and pull on the tie rod assembly. A little looseness is normal here, so experience and frequent checking will be a big help in catching the bad ones.